Okay, I think everyone is here. Prokavi, maybe you may want to start.
I think I'm muted now. So,
Yeah.
do you hear me now?
Yes, I can hear you.
Okay. Uh, okay then. Hi everyone. Thanks for joining us today. So I don't know if you see my screen and my presentation. So today we will be with vFunction and Kloia teams together. So we will be talking about accelerating application modernization with vFunction and Kloia. If you ever heard about vFunction, so if you've not heard about vFunction, so it's a AI-powered architectural observability and refactoring tool. So yeah, uh, so let me share my screen. Uh, okay, I think you see it now. So before starting, so let's introduce ourselves. My name is Orhan Burak Bozan. I'm a managing partner at Kloia, focusing mainly on application modernization. So for the last several years, I've been working with teams that are trying to move away from legacy architectures and adopt cloud-native, scalable, and more reliable systems. At Kloia, I spent most of my time at the intersection of technology and delivery, helping customers designing their modernization strategies, aligning with their business goals, and then actually execute them in real projects. Today, I and Baran will be sharing what we see in the field when it comes to modernization and then how we approach these challenges at Kloia. And then we will hand it over to Sam from vFunction team for deep dive into vFunction and then a small demo, I think. Yeah, Baran.
Yep. Hi, everyone. I'm Baran, a software architect at Kloia. For the past 5 years, I've been working with various customers on application modernization and microservices transformations. And today, I will share some of the patterns we see in these journeys and how we approach them together with vFunction. Maybe Sam, you can introduce yourself as well.
Yeah, hi everybody. I'm Sam, the Solutions Director at vFunction. My role really is to showcase and explain how our tooling works and how it can solve application modernization challenges. But that's enough from me. You'll see me later. So I'll hand back to you guys.
Thank you, Sam. So, before we talk about the modernization itself, let me give you a quick snapshot of what we are doing as a Kloia today. So, we work with more than 200 customers, so across different industries and regions. We currently serve customers in 17 current countries, and including like USA, UK, like Europe, Middle East, as well as Africa and Asia. On top of that, we have 6 offices in London, Istanbul, Netherlands, India, United States, and then Dubai. Our team is about 70 plus people spread across 7 time zones, and we have been working fully remote from day one. We are organized into 5 divisions: cloud and DevOps, app modernization, QA automation, observability, and generative AI. And from a competency point of view, we have more than 100 certifications, mainly on AWS and like other leading cloud providers. So as you can see here, modernization is not a side topic for us. It's one of our core practices, and it connects very closely with everything else we do. Uh, okay, when we look at modernization projects in the real world, there is a pattern we keep seeing again and again. Uh, Most customers have large legacy applications that have been evolving for 10, 15, or even 20 years. And over time, these systems accumulate strong coupling, circular dependencies, and shared databases that are very hard to manage. And usually, there is very limited domain documentation. The real knowledge about how the system works lives in the heads of a few key people, and then imagine when those people are busy or leave the company, it becomes a very serious risk for that company. Because of this, a feature delivery slows down, and teams are afraid of touching like certain parts of the system, and then because changing one thing can break something else completely different. So when we say modernization, the reality check is this. So the main blocker is not just clouds, not the Kubernetes or not the infrastructure. The reality check, the main blocker is the underlying architecture and then lack of visibility into that architecture. And maybe you know or not. So let's why do organizations decide that it's time to modernize? Let's talk about that one. So in our projects, we have seen that there are a few common triggers that come up almost every time for triggering modernization. So the first one is cost reduction. For example, moving from Windows to Linux, or from SQL Server or Oracle to Aurora. And then if you do that moving, you can immediately reduce your licensing and infrastructure costs. The second one is scaling and performance, of course, especially during peak traffic. As you know, legacy architectures often struggle to scale predictably, and this leads to incidents and firefighting. The third one, and another trigger, is the application downtime or instability. So when the critical systems, legacy critical systems, keep failing, and modernization stops being a nice to have and becomes a necessity, actually. And the last one, last but not least, so we also see a strong need for speeding up release cycles. So many teams start with releases every few weeks, but they want to move closer to daily or even multiple deployments per day without increasing the risk. And of course, security and compliance requirements becoming stricter every year, and old platforms and architectures often cannot keep it up. So modernization usually starts from one of these pain points or many of them, but very quickly turns into a deeper conversation about the architecture and then how the system is built. So to handle these challenges in our customers in a structured and repeatable way, we use what we call the Kloia modernization playbook. This playbook is the result of many modernization projects across different technologies and industries. So we first begin with assess. In this phase, we focus on discovering the current architecture, the domains, the dependencies, like all the DDD components, as you know, and we want to understand how the system really behaves today, not just how it looks on old diagrams. And then we move to plan. In this stage, we build a modernization roadmap, often aligning with such AWS programs such as MMP or MAP, when that makes sense. The goal is to prioritize the right pieces, reduce risk, and make sure the business value is clear. And then the third phase is the transform phase. This is where the hands-on work happens, the actual coding phase, actually. So it could be replatforming, refactoring, but in many cases, splitting the monolith into modular components or services and so on and so forth. Different customers here need different combinations, like combinations of refactoring, replatforming, or re-architecting. But the goal is always the same for everybody: a more scalable, maintainable, and resilient architecture. Finally, we have evolve. And then in this step, a modernization is not a one-time project. It's not a big bang. So it's a continuous journey. And in this phase, we focus on cloud-native practices like CI/CD, observability, and then keeping the architecture, the modernized architecture, healthy over time. So it does not slide back into a monolith, of course. So this four-step playbook is the backbone of how we run our modernization engagements. And as you can imagine, here the most difficult and time-consuming part is usually the early discovery and dependency understanding phase, which is the assess phase, of course. because we have to understand the system that we need to modernize. At this point, I will hand it over to Baran, who will walk you through where projects typically stall and why architectural visibility becomes a real turning point in the modernization before Sam. Yeah, Baran.
Yes. So hi again, Baran from Kloia. I'll pick it up from here and walk you through where modernization projects tend to get stuck and how we unblock them. So the point where modernization typically stalls is when teams try to understand their actual architecture. So manual dependency discovery is slow, module boundaries are unclear, and because the effort is unpredictable, teams do not know where to start safely. So we hear the same sentence in almost every project. We want to break the monolith, but we don't know where to cut. That uncertainty adds like months to the timeline. So over the years, applications accumulate architectural technical debt, not just code issues, but deep coupling that only shows up at runtime. So static analysis tools cannot see the real behavior. They cannot show you the actual flows between the components or how a critical part of the system is being used. This creates what we call the invisible monolith. You can see the code, but you cannot see the architecture. And if you cannot see the architecture, you cannot confidently modernize it. So teams often try to solve this with traditional methods, static code analysis, manual refactoring sessions, APM dashboards, or even full rewrites. But static analysis does not reflect domain boundaries. And manual refactoring is slow and risky, and APM tools focus on performance, not architecture. And as Brock said, Big Bang rewrites usually fail because hidden dependencies surface too late. This is why modernization initiatives stall or lose momentum. The tools simply do not reveal the true architecture. So that brings us to why we partner with vFunction. vFunction provides exactly the type of architectural visibility that large legacy applications need. By combining static and dynamic analysis, it uncovers real runtime dependencies that are impossible to map manually. It identifies true domain boundaries and turns architectural complexity into something you can measure and act on. For us, vFunction is not a replacement for modernization, it's an accelerator. It gives us the insights needed to move faster and de-risk the entire journey. So here is how vFunction fits into our modernization playbook. During the assessment phase, it gives us the architectural observability, allowing us to understand the system's real structure within days, not months. During the planning, it provides complexity maps and domain insights that help define the right modernization strategy. And during the transformation, vFunction generates concrete refactoring tasks, helping our delivery teams focus on implementation instead of investigation. And during evolution, it enables continuous architectural health checks so the system never drifts back into a monolith. This combination, our playbook plus vFunction's insights, is what makes modernization predictable. As you watch the demo, I recommend focusing on a few key things. First, notice how the combination of runtime and static analysis reveals architecture that was previously invisible. Second, pay attention to how the tool suggests domain boundaries based on real behavior rather than code structure. And third, look at how technical depth is quantified and prioritized. And finally, see how output turns into actionable refactoring tasks that can be integrated into your existing delivery workflows. And with that, I would like to hand it over to the Sam from vFunction team for the deep dive and live demo.
Perfect, thank you. So we can flick to my slides. Here we go. So for those of you who have not met vFunction as a technology before, as we've just seen, is a modernization tool powered by Gen AI. And it's all about modernizing our legacy applications, Java and .NET applications, to be cloud native. So that could be breaking monoliths into microservices. And that's going to be the demo I'm going to do today. Actually integrates seamlessly with code assistants like QDeveloper and GitHub Copilot to actually remediate any separation and technical debt elements that it needs to do so. So you'll see that in my demo. What I'm going to do to start off with, though, if I move my slide, I'm not moving my slide. Let's just switch my slideshow slightly. There we go, that's better. Just start off with a little bit of context of kind of why you need vFunction. So this is a message from X here, a kind of an industry leader here, I think. So showcasing modernizations. I'll read it for you. Claude 4 just refactored my entire code base in one call. Claude being obviously a code assistant. 25 tool invocations, 3,000 new lines of code, 12 brand new files. It modularized everything, broke up monoliths, and cleaned out spaghetti. But none of it worked, but boy, was it beautiful, is his comment there. So really the problem with just using code assistants by themselves, I mean, they're good at writing software code, and they're good at seeing source code in front of them. But as we've just kind of learned in that process, they rely on static data. They have no indication or understanding of how applications run in real life, no understanding of business logic, contextual flows, things that only happen at runtime. And for larger, more complex applications, they just can't ingest all that code base in one go. So you'll start asking a question and it will say it has no space to do that. What vFunction provides is that data set. So it provides this understanding logically of business logic in our applications, runtime dependency requirements, and can cope with really, really large, complex enterprise applications as well in its size. The image here just represents a modest application and a single class dependency from a static level. So you can see the mess that you would look at under the covers in an application. vFunction obviously provides this context to code assistants as well, as you'll see in my demo in that process as well. So this is how vFunction works. We deploy it into your environment. It's not a SaaS technology. It's going to collect potentially sensitive software architecture data. And we use a software agent to do that dynamic runtime analysis. We want to see an application in its running state so we can understand how it works. All that data is collected by a software profiling agent. And we normally use non-production environments for this. So a QA or test environment while testing is happening is perfect. It also takes in the application binaries. We need to say the existing application structure so that we can modularize it and logically separate things out. So we use the application binaries for that to give us compile time dependency data. The time it takes to do that analysis is really, really quick. So it's the amount of time it would take to showcase the functionality of the application. So no more than a couple of hours. It then provides a visualization, a domain design that we're going to see, a logical separation of business logic. It's fully interactive. So the architect can really align that to the business requirements for the modernization there and see the impact that has on a modernization plan in stage 3. So we want to modularize, logically separate out the business logic. We want to correct any technical debt within the application as well. Anything from dead code to cloud compatibility issues that we might have if we want to move our application into a serverless technology stack there as well. So vFunction actually creates to-do tasks. So this modernization plan is sets of tasks that have a description, an effort estimate, a prioritization, and why we want to do it. But also vFunction does the prompt engineering. So we can use a code assistant like QDeveloper or potentially a Copilot to do that for us. Supervised obviously by a human developer, and vFunction has a feedback loop. So we're going to analyze the application on every release, see that we've corrected the to-dos, the modularization, the technical debt successfully. And then when we have logically separated business logic, we can just pull that out. So we have a step in stage 4 that extracts the existing code base into new software projects aligning to the domains or business functionality of the application. REST API enables that for us as new software projects all ready to run. And then if there's a technology requirement to improve things slightly at a technical stack level, we can apply upgrades to versions and frameworks and assemblies within that application. So we can run in a more native way, in a more modern way, potentially a more open source way there at step 5. We see a lot of .NET framework applications to move into .NET Core to leverage the open source capabilities there, remove the licensing constraints. The whole process here works whether it's a monolith, modular monolith, or a distributed application. We just get different to-dos in stage 3, depending on whether we're combining or splitting business logic out. And there's also governance capabilities as well. We can set rules and policies and document how software architecture evolves over time, and track that kind of drift and evolution that happens in stage 6 there. So what I'll do is I'm going to show you all this in real life. We're going to use maybe a really simple application first, to show you the concepts. And then we'll look at some good and bad software architecture as well, so you can see kind of what's happening. And I'm going to start with a really simple, happens to be a Java Spring application, an order management system here. And we've run that dynamic and static analysis already. And this is the out-of-the-box view. So what vFunction's done is it's logically separated out the functionality or business logic in our application into domains. So in domain-driven design theory, a software architecture concept, vFunction is really aligning to that. So the circles or spheres here represent my domains or functionality in my application, but logically, not physically. So we have domains like inventory, order, shipping, payments. So domains I would expect to see in my order management system anyway, but this is all identified automatically by vFunction for us. They might interact with each other today. So this is just a monolith, a singular application. So they might interact via method calls or communications internally in the application. And that's the lines between the domains. Think of them as dependencies, if you like. And then if we just focus in on one of them, this is fulfillment here in the middle. It's actually quite critical. It has a high runtime. As you can see, it's quite critical and central in our application here. But obviously to do that separation, vFunction has to define some boundaries, some entry points. In our case, we have 2. We can see the call tree flow and a component-based view. We can see and understand what this does, how it works, and the data sets it uses in this process. Then it's underlaid the software requirements to deliver this, technically the classes, and the resources and constraints the fulfillment runs with or against. Does it talk to database tables? Does it execute stored procedures? Does it talk to other applications or a mainframe, for example? Does it write to a log file? All of these things are focused within that domain. The color coding on my screen is what's called exclusivity or bounded context. But what's the logical or actually physical separation at the code base right now? Can this run independently? Does it require components from elsewhere? And that's the color coding. So green being highly exclusive and unique, good logical separation already. Red being bad. We need to do some work on modernizing that. The architecture is not fixed. So it's a suggestion, it's the best mathematical and scientific fit. But we can align this to meet business requirements as well. I have 2 shipping domains here. I combine them together to one if I think that's going to be the best fit, and it will give me feedback on whether that's a good or bad decision, and the impact that has on my modernization plan. But fully interactive, I can define my own domains, inject entry points, totally align this to a new target architecture if I want to adjust it. The outcome of this, though, is this modernization plan, the to-do task. What do I need to do to unravel the business logic, correct any technical debt within the application architecture, and make it cloud compatible? Lots of different to-dos in this application, anything from unnecessary business logic, we call that dead code, cloud readiness issues, where in my case here, I'm writing to the file system. If I want this to be serverless, the file system disappears. We need to find a new way of doing that business logic implementation, entangled software components or classes that we need to break apart, or even exclusivity at the data layer. What we can't have is 2 separate running services trying to write into the database table at the same time, or breaking a transaction chain. All of these to-dos, vFunction generates a prompt for us. And these are big comprehensive prompts with lots of context around the software architecture. To show you one, I'll just flash one up here. So this is a prompt to solve remove a domain dependency between 2 domains, but multiple pages here with the strategy to follow, the quality metrics. So we can use a code assistant really well, or even a human developer gets really good context there to solve that. So if I wanted to solve one of those to-dos, I can use my code assistant to do that. So let's have a look at Amazon Q Developer as a code assistant in my IDE here, Visual Studio Code, but fully integrated with vFunction. So it's integrated via a capability called MCP. It's an interface that code assistants use to talk to tools like vFunction. And what we do is expose a set of tools. So tools like get the to-dos, understand the software architecture, what's a domain, extract out services. These tools are all provided by vFunction to the code assistant. So we can see and understand that logical architecture that it can't understand by itself. So I can ask it questions. As a developer, I come in the morning, we want to fix some of these to-dos. So what are my to-dos? And it should go away now to vFunction and get that list of to-dos that we were looking at in line. It's probably going to ask for validation to run that. So this is a vFunction prompt to get domains first. It wants to understand the logical model. Then it wants to get the to-dos. And they should be the same. So it's going to talk about, also got some frameworks to upgrade, the bit out of date cloud readiness issues, just like we were seeing, architectural issues, dead code, etc. And even some Azure compatibility issues separately as well there. Obviously not affecting AWS as it's not calling that out, but some Azure issues. And then you can go ahead and fix these. You can get these prompts from vFunction, context of the architecture. So fix the cross-domain service call to do. And it will go and get that prompt from vFunction, analyze our dependencies, the source code it has in front of it, and go away and remediate it. There's it getting the prompt, etc. For the benefit of a speedy demo, you'll want to see the impact that this has back on our application. So jumping back into vFunction, and this is the same application after we've reanalyzed it, after we've embedded some of those changes. So this is the next release of my application here. And we can now see we've massively improved the domain model, the design here. So what we have in front of us still are the domains. The color coding has changed. We have really high exclusivity, good bounded context, good separation in our application here. We've actually removed some of the dependencies, but I can validate this by checking the to-dos. So if I go back to the to-dos and check the ones that are done, vFunction will only mark a to-do as done when the problem no longer exists. So if the code assistant maybe failed to do that appropriately, won't be ticked off by vFunction. If a human developer maybe doesn't align it as expected, again, it's not ticked off and not marked as done. Any new to-dos will also appear. So as new business requirements are being deployed alongside our modernization, we can track them and manage them as well. So we can constantly evolve the architecture. When I have logical business logic, and you'll see in some real examples I'm going to show in a minute, the real difference between logically separated business logic that can run by itself, independently scalable, independently resilient, as opposed to tightly coupled logic. But in my example here, let's just extract out one of these domains. So I'm going to extract out order. So order is this one here. Order does three things. I mean, it's logically separated. It has high exclusivity. It can run by itself. But it does three things. So what does order do? It does create multiple orders, create a single order, and fetch or get orders. So that's the three capabilities of my order logic that we're going to extract and recreate. So what I want to do is click extract here, go to service creation, and configure how I want to extract this out. What I can do is generate REST API endpoints. So we're exposing and pulling out backend business logic. We want to be able to talk to that. We want to be able to integrate that with our applications. vFunction will wrap those entry points we were looking at with a REST API endpoint and define the data transfer objects for us so we can talk to it easily. What it's also done is for any non-business logic, maybe logging and validation capabilities, it's put in a new shared library for us. It's actually one of the domains behind, so we can manipulate that as software architects if we need to. But I'm going to take all those. The process is to download these definitions there at the top here. So it's the top three. I've got a technical definition file, which has got all of the software components or classes, these new API definitions, the libraries I need. In my case, my technical Spring config for my software project, where the database is and all of the configuration. Generate some documentation that we're going to need for my test harness. So what are the new REST API endpoints? And same for the common library. And then we have this code copy utility that's going to build this new software project for us in our development environment or in the code assistant. So I could ask my code assistant here to do the extraction for me. I could just ask it to extract out the service, extract out order service, and it will go ahead and do that download piece for me. But it's quite difficult to see. So what we'll just do the same thing on the command line instead. So here we are now in a developer's workstation. I have the existing source code, the artifacts in vFunction, and that code copy utility. So this is the existing source code for the order management application. What we need obviously to run this application. We're going to run that code copy utility against it with the definitions of the domain from vFunction. the existing source code and the name of the new software project we want. Basically, it parses the existing source code repository, pulls out what we need, the software components, the libraries, the configuration, builds a new software project, populates it only with the existing requirements that we need for order, the create order, create multiples, and get order, minimizes all the configs. So I have the smallest possible project, the best possible runtime for this capability. This is independent of vFunction, so I'm just going to run and test it so you can see it working. So this is just building my binary, my compilation process, building my jar file, in my case, for my Java application. And then we can just run this to test it out. So this is kind of unit testing the 3 capabilities that we're exposing for order outside of the monolith. We pulled it out of the monolith. And I've just loaded into this API test tool the 3 capabilities that we added the REST API endpoints for: create order, create multiple orders, and fetch or get an order. So we can just execute those with the example data set coming out of vFunction, and we're just running them as API calls, and each one is querying successfully. So what we've just done is we've kind of analyzed the application's logical business logic, defined those domains automatically, adjusted them to meet a few business requirements, taken the to-do plan, that modernization plan, prioritized for our particular needs, corrected the modularity, made sure it was compatible at the data layer, so all of that exclusivity, so we don't write to the same database table. We've corrected any technical debt, like removing any unnecessary code, removing dependencies, breaking bigger components into smaller pieces, and made it compatible with the cloud requirements we need. So maybe we want to run in a serverless app function like Lambda, we can make sure it's compatible. So we have now a running capability for just the individual domains pulled out of the monolith so they can run fully separately. And we can mix and match technology as well. So we can use high performance requirements for the core elements of our application, maybe always on containers, and then use cloud functions like Lambda to run things like payments that would be sporadic in that process. Just going to show you some real world examples as well. So let's look at something a little bit more scaled out. This is an online bank application. It's a bit bigger, substantially bigger than we were before. So 4,000 or so classes, definitely in the million lines of code department. And then this is the vFunction out of the box view for it. We can still see that same representation. The domains are things now related to like loans and payments, so things you'd expect in a banking application. But what we can see is that the architecture logically is quite well separated on the right-hand side here. The domains look quite independent. We need to work on some of the exclusivity, but they can work by themselves. It's actually quite a modular architecture already. Actually gives me an exclusivity metric that's quite high. I have good modularity to start off with. There's some coupling over here. So domains that obviously interact with each other are good. The ones that are dependent on each other, not so. I think I have a few circular dependencies as well, the ones that are emerging through here. So they're bidirectional dependencies we need to break. Obviously, a few modernization to-dos, but a good architecture to modernize. We're going to get really good success here, refactoring this out into separate services in a really timely manner, as opposed to something a little bit more scary. So this is a car rental application, a car shop application, double the size again. So definitely a number of million lines of code here, 11,000 classes. Maybe 5-6 million lines of code. So yeah, definitely much bigger, very entangled business logic. In fact, I don't think any domain is independent. So all the business logic is raveled together, lots of dependencies between them that we need to unravel first. Obviously, vFunction gives us this visibility. Without this visibility, we would obviously just jump in and start pulling things out, and it's just not going to work. So we have that modernization plan to modernize this by pulling the right things out at the right time, prioritizing our modernization and correcting the right things, ideally using a code assistant. To show you how messy this is at the source code level, I'll just show you the static dependencies for a single class. And this is a bit like on my slide earlier. So in this application, this is one single class and the dependencies between them. So if we were just looking at using a code assistant to modernize this application, this is what it would see with one class in front of it. If you had to load all of the classes in, I think the code assistant is probably going to break. So this is why it needs that context of vFunction, obviously to understand the logical architecture, but also to identify what the technical debt and modularization requirements are that it can't see by itself. It can upgrade to the latest framework and the latest version, but it can't see these problems by itself. So just jumping back to wrap up some of my slides. So let's just go back to my slide deck and play this again. So here we go. So we just had my demo. Now I've kind of got an example case study here for one of our customers. So you notice on my slide at the very beginning, 15x, whatever does that mean? So this is a really good example of what 15x or 16x in this example modernization is. So this is a telecoms provider, a mobile top-up app. They were originally planning using their resources to do a modernization here to refactor the application, and the original plan was 12 months for this. That was what actually they were quoted for, to do the modernization manually without using vFunction. Using vFunction, they managed to modernize this application and refactor out all of the domains in 3 weeks. So that's the design, the analysis, the modernization, mobilization, and the extraction of the services. And that's using obviously a combination of vFunction and the GenAI capabilities. So 16x doesn't mean anything to me, but 12 months to 3 weeks makes a huge difference. Scale that up to big complex enterprise applications as well, and you can see this modernization is a practical opportunity to do. We can refactor and re-architect these applications really quickly, get them in a cloud native state without having to go through multi-year projects to achieve that. And then we can modernize lots of applications for the whole portfolio. So this is pretty much almost my final slide here. So kind of why do you want to do this? So this is focused on AWS. The same examples apply. So using vFunction and code assistance, we can transform a lot quicker. 15x didn't mean anything to me, but the 1 year, the 12 months to 3 weeks does. So that's a good example. And we can unlock cloud native capabilities for our monoliths. So we can use, obviously the monoliths can be broken apart and can be using serverless and container technology, but we're unlocking the other benefits of cloud as well. The data layer, the UI layer are unlocked, getting us that agility that cloud offers, rather than just rehosting in simple compute services. We want to obviously reduce the level of technical debt, but also do that at scale and prioritize it. We've got really, really large, complex, bigger than enterprise applications going through vFunction right now. So like 100 million lines of code for a big insurance provider in Europe. So huge, huge, complex applications that without this technology, you wouldn't be able to achieve. So you can do this at scale there as well. And also, everybody's also moving to adopt AI. Obviously, you've seen we're leveraging code assistants in a really safe way, treating them with the right respect of what they can do, but also validating what they're doing, but also expose where within our applications AI and GenAI can replace existing business logic by exposing that business logic, as you saw at the beginning of my demo there. And this is all could be built in a repeatable process, so we can modernize whole portfolios within this as well. So the context of my kind of takeaway message for everybody is modernization itself needs modernization. And that's why we're using kind of vFunction alongside AI here. So we want to understand the architecture and use AI, kind of rewrite this playbook for modernization. Perfect. So back to the Kloia team if there's any further slides.
No. Thanks.
Questions, I guess, then. Do we have any fun and exciting questions?
Yeah.
So I think there's a few questions here in the chat. So maybe I'll tackle some of the vFunction ones.
Yeah, we will start from. Okay.
I start at the bottom, shall I? Let's read from the bottom. So,
Okay.
oh, you've highlighted one. Perfect. How long does dynamic analysis need to run in production to get accurate results? Is test environment data enough data? Really good question there. So we try and use non-production environments like test environments because it's easier to deploy technology that way. So we're doing modernization normally as part of a project. Development teams are using the software. It makes sense to use their environments. And then we have a higher control over what's happening. We don't affect what's going on in production. Technically, you can use vFunction in production as well as in non-production environments. The way a test environment normally works, normally roughly represents production. It's not expecting to see all business logic running. The way the machine learning and data science works within vFunction means we don't need to see everything. and see the majority of the context so it can understand that logic. It will actually identify what's missing. Any missing test cases, it will call out for us. So if there's a set of business logic that's not run, it has two sets of data, remember, the runtime view and the static dependency data, so we can see what's missing. So it'll identify that for us. Maybe we can put a test case back in to test that functionality. Or if it's not practical, we can use a production instance to do that as well. The time it takes really is to showcase the majority of that business logic. So if I had a unit test suite or a regression test suite maybe that took 2 hours to run, that analysis takes 2 hours. If I'm using a production instance and it's quite heavily used with all of the functionality running all the time, could be 5-10 minutes. It only needs to see it once. So that analysis is instantaneous at that point. The way vFunction works is it's embedded into the software development lifecycle. We want to see this every release. We need to track the technical debt and the improvements we're making, and we need to validate them. So every release we want to do it, we want to be as lightweight and easy as possible. But yeah, it's a good question. Hopefully that answered that. So let's take the next one. What we got next? How does vFunction handle, oh, no, we've got this flashed up. How do we calculate the technical debt score? Does it only check the dependencies or does it also measure code complexity? Yes, it does. So it does both. So there's multiple elements of vFunction from the scoring. It does that really quickly at the beginning. There's other dashboards I didn't show comparing the whole portfolio of applications. At the very start of a project, we want to find the right applications with the best business case for modernization, and technical debt scoring is the best way to do that. It's looking at the entanglement and complexity. It's looking at some things like unnecessary business logic and some legacy elements in the application to come up with a comparable score across the whole portfolio. And we're looking to do refactoring to build the best business case to get the most benefit. We're looking for applications with the largest amount of technical debt. So there's dashboards to look at that. It also looks at risk and complexity for modernization. So it's looking at kind of volumes of dependencies and dependency depth there. It also estimates how long it's going to be, how many to-dos there were going to be. And this is all up front at the very, very beginning before it's even looked at that domain architecture. So you can very quickly, rapidly identify that. So just looking at the complexity logically also enhances that as well. But yeah, again, quite a good question. But we like to use that technical data up front, but it's a great scoring. vFunction also calculates engineering velocity metrics. So you can start to see the return on investment right at the very beginning. And you'll see as the modernization progresses through and we modularize the application, it lowers those metrics down. So you can see obviously the impact that it's having in improving engineering velocity as we start improving the application structure. And then release cadence can improve. The amount of time it takes to add new business needs improves as the modernization occurs there as well. But there's all metrics in vFunction for that. Next question. How does vFunction verify that the refactored services still behave the same way as the original monolith? Good question. So vFunction is designed to be used ongoing as part of the software development lifecycle. Most people obviously start using it as a project and there's a business need to modernize, and we use the tooling to do that. But it's actually designed to be used ongoing to manage the software development lifecycle, to manage and monitor technical debt in our monoliths and distributed environments. So we're basically going to be comparing that functionality in the before and after state. In that design and analysis view we were looking at in vFunction, we're actually simulating what's going to happen. So that kind of target architecture view is a simulation, and it's telling us whether things are going to work or not, and it's going to give us to-dos to correct things. So it's very accurate in what it's doing, very risk-free, and it's all about that data set at the beginning. Having the dynamic runtime analysis means we see the functionality running in its running state. We know exactly the paths in the application it runs through, and we compare them, those cool trees and the component diagrams I showed in my demo. We can compare the before and after in that process. We'll also generate things like the new endpoint test cases for the REST API endpoints. So we can obviously retest that functionality easily afterwards. And as part of a modernization journey, we normally do incremental modernization. We follow a process called the Fig Strangler pattern. We strangle out business logic from the monolith and start running it alongside. So incrementally modernizing and pulling things away. which means if we needed to, we could revert back to the original code. We're not changing the original monolith. We're kind of extracting them out and running them independently next to it until there's nothing left in the monolith. So a very risk-free way of modernizing without any big bangs, scary big bangs. But yeah. Any more questions? Loads. How does vFunction handle missing or cold code paths which are not executed during profiling? So one of the to-dos vFunction created was called dead code. So that's technically callable code. So code that should be called, but we don't see it at runtime. That's different to uncallable code that I know a static analysis or a tool or an IDE can find, SonarQube can find, and we can get rid of those. This is technically callable code, but we didn't see it running. And that is subjective based on the environments and the data sets we have. It could be a missing test case if we're using a test environment. It could be something that runs once a year, end of quarter, or we just didn't catch it at that time. So it is a subjective item. We don't ever miss anything in vFunction because we have both dynamic and static analysis. Even if we just saw one thing in the application as part of kind of recreating it, we wouldn't break any functionality because we have the static dependencies as well that we will add back in as part of that extraction process, unless the architect has agreed that the functionality is not needed and it is truly unnecessary code within vFunction. Say it's dead code, and then it will be removed from the compile time dependencies at the conversion and extraction point. But it doesn't need to see everything, but it is going to tell us if something's missing. So you'll get a to-do, say we're missing test case, you're going to get a to-do with if it thinks it's dead code because it's aligning it to business logic, and something that we can deprecate and remove out. In the process of extracting out, if we miss something and something is missing in the final application, come back into vFunction and extract it out. You saw that extraction piece. It's really quick. It takes 5 minutes to extract out a domain. And we can add and manipulate that if we need to. But I don't see that being a problem on a day-to-day basis. So, all good. Next question. So how big is the largest code base? So at the moment, I think one of our largest ones is an insurance provider in Europe, 100 million lines of code. It is probably one of the biggest applications in the world, I think. It's really big, and it's like 35 years old. I think that's certainly one of the largest. There's a UK government entity right now with something very similar in its size. Yes, same kind of complexity. So scales up really big. We did have a .NET application out of Australia or New Zealand, I can't remember. It supposedly was according to Microsoft, was the biggest .NET application in the world. So they can be really, really big and really complex. Obviously, the modernization takes a bit longer, and you have to start in one place. But the more mainstream ones are enterprise level kind of applications, 10,000, 50,000 classes, that kind of range. I see the most of, and occasionally there's small ones. So a lot of use of vFunction is portfolio level. So it won't just be one application. It won't just be that big mega monolith, megalith. It could also be something a little bit more manageable and a range of sizes. And occasionally there's small ones. We'll analyze them in vFunction. No need to refactor them. They can just be transposed and replatformed maybe into a container or use a kind of an application running service in the cloud to be more efficient. You don't need to modernize everything fully, depending on its size and complexity. But yeah, can be really, really, really big in the process. But yeah, are we almost through? God, there's so many questions. How does the tool determine optimum domain boundaries? What signals does it rely on? So the core data set for doing that dynamic or doing that domain design is using the dynamic analysis. Think of it as extracting out call flows. So when some execution of some functionality happens, we're calling methods to method to method, calling to database, calling to other application, instantiating objects. All of that kind of thing happens. vFunction takes all of that for all of the different scenarios, puts that in a kind of giant mesh, of all the possible paths, and then uses data science algorithms to logically group them based on how they're executing. So do we have kind of key elements that run together? Do they share the same data sets? Is it talking to the same database tables and event queues? It's using that context to logically separate them. In domain design kind of concepts, it's all about grouping things into communities based on how they run and operate. So it really requires that dynamic analysis and the data set there. But yeah, very accurate way of separating things out based on how they're being used. And obviously that's the best and most efficient way of refactoring, re-architecting an application. If something's used in a particular way, you want to logically separate out so it can run together. So it takes into other accounts, like the data sets and things as well. In that process. But what it doesn't do is look at the existing structure that's underlaid afterwards. That doesn't give a very good view. Trying to carve out code based on the fewer dependencies, the better, is not going to give an efficient and scalable and resilient application. But the dynamic data set is the key. But yeah, all good. How are we doing? Do I have even more questions?
So Sam, actually there are two questions that are really similar, and the first one is this one, and maybe we
Yeah,
can.
this is quite a good question, actually. So modernization is kind of split into quite a few different segments. vFunction is all about modernizing business logic that should be in the back end of the application. We all know, or anybody in this space knows, that business logic is never where it should be. And it's likely to also be in the database in, say, stored procedures, PSQL. Business logic was a lot easier to deploy that way with people trying to get around the software development lifecycle controls. I'm probably caused some of that damage a number of years ago as well, creating stored procedures because it was easy. Also, it's embedded in the UI, or I might have a thick client UI if it's a legacy application, something that runs on a desktop and there's business logic in there. So vFunction is going to try and find and identify that business logic based on how it's executing in the back end and identify where it should come back in the application. When it comes to a stored procedure, it will see and track that stored procedure call from the calling application. So let's say I have a Java application, a particular method from a particular domain, calls a database table, calls a stored procedure. vFunction will see all that. When it's a stored procedure, we'll see the impact it has on the database. Did it write into a particular database table? Did it call another stored procedure that wrote into a database table? It's trying to make sure the data layer remains exclusive, so we don't break transactions in the refactoring process. But the data set it's using is obviously really handy in data modernization as well. We can potentially vertically align the data structures and schemas with the service architecture that we're creating. By adjusting that, we can identify what stored procedures are being used and why. Can we bring that code back into the existing application? And we can use code assistants now to do that. They can convert that PSQL code into Java, into .NET, and we can pull that back into the right place of the application. I've yet to see a project that didn't have stored procedures, and people want to get rid of them. It's not very good for the software development lifecycle. Definitely not best practice anymore, and it does hinder the move to open source database technologies and managed databases as well. So a big part of modernization, vFunction's looking at it, but it's not doing that piece, but feeding into that model as well. Just like at the UI level, we might pull data out of a thick client, but we're not rewriting a thick client to a modern UI. That's another part of the project that our friends here at Kloia can help with too. And the same with the deployment and the DevOps cycle afterwards. You need a good, obviously, DevOps cycle in that process. And our friends here are really good at doing that. So the data modernization, controlling the vFunction process, doing the UI changes, you need to speak to Kloia for that. And it's probably the same for the second question, was it? Yeah, so overlapping slightly, but I answered it in the previous one. So we see all this during the runtime analysis. It's an important part of creating the separation and bounded context in domain design. The way things need to be separated, we need to look at the data and objects moving through the application, and certainly applies quite heavily while maintaining kind of transaction chains where things are a little bit more complex than just writing into a database table. But all the data sets there, and it does take that into account as part of its analysis. My takeaway at this point for anybody, though, it really is vFunction is very flexible. This is not a upload your source code, press a button and hope for the best type scenario. This is a flexible platform designed to meet kind of complex modernization requirements. Everything from evolving that architecture, being fully interactive, aligning with a software architect to meet best practice. It's not subjective in any way. It's not forcing any technology changes. It just gives you that roadmap, whatever you want or decide you need to get to that chosen path, but providing the feedback and advice of whether those decisions would be optimal or not. And they might just be a business decision rather than a technical decision to make those choices. But it allows it either way. But it gives the feedback so you know whether things are going to take a bit longer in a particular way, and they can be discussed as a business choice or not. But allows you to do any of those things. But perfect.
This is for me, I think.
Thank goodness.
Okay. What type of customers come to Kloia for modernization? Mostly the companies with long-running systems, like as I mentioned, 10 or 15 years old code bases and legacy ones, and they mainly come to us and to reduce their costs or improve their performance and speed up delivery mostly. And then we help them to choose the right path and execute it step by step. I hope this answers your question. Okay, so we're done with all the questions. And yeah, do you have anything to say, Sam? So
I just want to thank, obviously, the Kloia team for inviting vFunction to join the webinar. Obviously, thank the audience for their time today, wherever you are in the world, or if you're watching the catch-up recording. Thank you for your time. If you think vFunction is something that might help with some complex modernization, please reach out to Kloia. They can obviously scope that and see whether it's a good fit for vFunction. But happy to discuss further with yourselves and Kloia as well. Around using vFunction for your modernization problems.
Yeah, thank you. Thank you everyone for joining us today. So I hope this session gave you a clear picture of the challenges in modernization and how vFunction can help accelerate this process. And a big thank you again to Sam and the vFunction team for the great demo, and then thanks to Baran for the technical deep dive. So as Sam mentioned, so if you'd like to deep dive or explore a specific use case about vFunction or modernization, or discuss your own modernization scenario, it doesn't matter. Feel free to reach out to any of us, and we're always happy to continue to the conversation. Yeah, again, thank you for your time and your questions and your engagement. Have a great rest of your day, and then we look forward to seeing you at the next DevOps Underground session.
Thank you.